Find the acceleration of blocks is asking. So I'll proceed in this way. We'll assume things here now. The weight m1g will act. There'll be normal contact n1. This n1 by the wall on the block, by the block on the wall. Then I'll assume the friction here F1 and the friction here F1. The weight m2g. Then the friction by the wall on the block. Okay, this assumption I'm doing here. Now what is the assumption I'll do is like, shall we do that the blocks will be at rest? What are the possibilities now? Go back yesterday the way we are discussing. The similar idea is what you should do here. What are the possibilities? The possibilities may be like M1 will, both the blocks will be at rest. M2 at rest, M1 moves. M1 at rest, M2 moves. Then both will move together. Both will move together means no slipping here and they'll be slipping. So many things are there, no? We have to analyze all here. That's why I directly brought a numerical things. What can happen? Both will be at rest. Both will slide together. Both will slide together means there will be no slipping here, they'll be slipping. Both will be at rest. No slipping here, no slipping here. That's the first case. Second case, no slipping, slipping. Second case this is. What about next again? They'll be slipping here and here. Third one. The other thing, slipping here, no slipping here. Next other possibility, slipping will occur. Okay, these are the four possibilities. Then which one I should do, sir? Like you are telling so many things here. Cross check one by one. Are you getting? Cross check one by one, then conclude. What happened? We wanted some sort of question formula so that we'll substitute, we'll get answer and we'll get a rank. Not possible. And you'll become engineer. Not possible. You have to fight no here. Okay, let's carry on. Huh? Now I'll start with a assumption like, shall we assume both are at rest? Means no slipping here, no slipping here. Yeah, you can start it. So what is the first assumption? I'm not sure myself I'm right or wrong. The first assumption, no slipping at all surfaces. Then the friction acting at all surfaces, what it should be? Static. First we'll calculate what are the limiting frictions at all surfaces. N1 minus, all these are calculation part, N1 minus F equal to 0. F1L equal to mu N1, 0.6. F is 40. 24 Newton. Then N2 minus N1 equals 0. N1 equal to F. So therefore N2 equal to N1, which is equal to how much? This will be equal to F, no? 40. Okay, the limiting frictions at both the places, it is in fact equal to just 24 Newton. Then weight of the block, we have some very nice information also there. Then M1G is how much this will be? 20 Newton. Here 20 Newton can act. Okay. How much M2G? M2G is how much? 40 Newton. 20 plus 40, can it be balanced? And here how much we are getting? Is it possible? Look at this, 24 Newton, can it balance these two? 60, not possible, no? But here 20 Newton can balance this 20 Newton. So is it correct? Not possible. At least from the diagram, what we can put it. At least from the diagram, now we can directly make a guess of situation. What is the guess of situation? No slipping occurs here. No slipping occurs here. Slipping occurs here. Directly looking at this, I'm as I make a condition here now. So I'll proceed here. What is assumption? No slipping between blocks and slipping between block M2 and wall. Now I'll proceed. M1G, the frictional force acting is F1. This is F1. M2G, so here normal contact N1. And what is the state? Will they be at rest? No, they'll be accelerating. Oh sir, what is this? That's what I assume, no. Slipping occurs between the wall and the block. So therefore, this will be moving down. And no slipping means with what acceleration this block M2 will move, the same acceleration the block M1 should move. Let's write equation. We'll solve for F1. If F1 is less than F1L, okay, fine. We are correct. We are on safer side. Means what we assumed is correct. Let's write the equation. Some students know, like, sir, same thing you are repeating again and again. I think it's correct, no? What the idea that was there in from the beginning, the same idea is what we are carrying on here. You may feel we are discussing many good numericals, but the fundamental idea is same, only one. There's a one equation on the block M1, then M2G plus F1 minus M2 equal to M2A.
Sir, whole we can consider system.
Yeah, anything. I'm writing equation. Directly you can write acceleration equal to adding up these two. F2L.
Sir,
Anybody value acceleration?
6.
We'll come and check the F1, that's all. In this equation, M1 is how much? 2. (20 minus 12), 8 Newton. What we assumed is correct. Problem over. Okay, not one block, 2, 3 blocks. Let it be any number. I think we can manage now. Sir, even you may get in exam like 3 blocks are there. Let it be. We are scared to do experiment. There is a major problem. What we are scared to go wrong. That's our biggest headache with us. Instead of 40 Newton, let me apply 10 Newton then. We have to check it, the condition. We have to check it. If I apply just only 20 Newton, let me apply it. Then you assume like this. First, no slipping occurs here. 20 Newton. 0.6 into 20 Newton. Or say like a 20 Newton you applied it. N1 is 20. Check all. Equilibrium possible, not possible. Okay. Then sir, maybe this is possible. Again work out. F1. You just apply 20 Newton. The similar way you have to carry on. Now instead of 40 Newton, you bring 80 Newton. Next 200 Newton. Like that you apply different forces. Assume any one case and check it. What is possible, what is not possible.
Sir, did you get acceleration equal to 6 or you took it as 6?
Open eyes my ear, please. How such a beautiful, like thinking also such a extreme. How you get it? I don't know. But like how I'll guess this. You are killing total physics here by the way you are asking. After solving, I'm getting just simple maths. No, what is there? Once you substitute and solve, what is there? Confirm yourself. Oh, this by solving we got it. How this is assumption? So some of you are thinking it such a way that you are killing the subject itself. Please analyze, calculate. No, what is there? How much of time will take my addition, subtraction, multiplication? Substitute all values. Check value of A. Oh, sir, substituted and solved it. No, so lazy that nothing. Just only Cartoon Network watching like that we want to watch. It's not about this one girl. In general, most of you just want to watch screen. You have to do calculations, all that one. You should be very fast in all these things. Sir, can you do this same problem for any other force? You can try for 80 Newton, you can try for 100 Newton, you can try for this one. Let me do this for 120 Newton. We'll see what conditions will arise. The same condition, 120 Newton, I'll bring it. Carry on. Already we have F1, F2, FL. No. So this is the N1, M1G. How to get the direction of friction? Who will balance M1G? I am assuming that they will not move. Because I am pressing hard, as they will not move. So are you sure? Blocks, no slipping, at all surfaces. What we assumed, is it right or wrong? How to cross check? Calculate the friction force. If it is F1 less than F1L, okay, fine. F2 less than F2L, what you assumed is right. We assumed it. Let's no slipping at all surface. Let there be no slipping at all surfaces. Okay, let's carry on the problem now. What is N1? N1 should be equal to here these things will change. 120, 72
22.
Newton. No. M1G is how much? M1G will be just mere 20 Newton. So how much this will take? 20 Newton. this will be 20 Newton, this will be 40 Newton. Forty, 20, and this can be 60. Look at F1. Very simple. So therefore, blocks will be at rest. So what I assumed is right or wrong now?
Correct.
Yeah, what we assumed is right. So again, who is the best friend now? The friction here. Again, see, horizontal or vertical, wherever you go here, no slipping, the friction should be static. Slipping occurs, friction should be kinetic. Friction should be greater than limiting. Now we'll go for, if a person walks on a ground, how the friction will be acting. So this is like a very complex one, just only I'll give some relative diagrams, because we have to take lot of other parameters. So only in a gross way, I'll just conclude here how the friction will be acting on a person. So when a person
along